This is the last video, hopefully last, for 1.6, right? Finally the last bullet point, absolute value. Okay, so what is absolute value? So far we have learned to recognize to solve linear equations, quadratic equations, rational equations, radical equations, equations with rational exponents, and we're not doing this one, equations in quadratic forms. We're not doing that one. Today, we add absolute value equations to our list, or right now in this section. Recall that the absolute value of a number is the distance the number is, from 0 on a number line. So given a non-negative number k, the generic absolute value, the absolute value of x equals k, can be solved directly from the definition of absolute value. Remember that if k is a positive real number, then x can equal k or x can equal negative k. So here, going back to the definition, absolute value is distance, okay? And then yes, from 0 to But the main takeaway that I want you to get is that absolute value is a distance. Remember that distance is a positive number, right? You can't be negative away from something. The closest you can be to something is 0, right? So you can be at a location or like in a location in a house, if you would, but you can't be negative away from your house. You're either at your house or you're not. If you're not at your house, then you may be 1 foot away, 1 mile away, who knows, right? But absolute value, what I want you to take away, the big thing here is that absolute value equates to distance. Okay? So absolute value does equate to distance. So here, just to look at this on a number line, like say, for example, number 1. So if on a number line, let's say here's 0, the absolute value measures distance we are away from 0, right? That's what the whole definition says. So the distance I'm away from 0 is 2.6. But we don't know if we're 2.6 in the right direction or if we're 2.6 in the left direction. So that's why the absolute value of x equaling 2.6 is equal to negative 2.6 and positive 2.6 because you don't know if it's on the left or on the right of 0. So in this case, I want you to think of negative more in terms of like left and positive in terms of right, okay? So now if I've got number 2, we like number 2 because the absolute value bars are still isolated. Whenever you're solving for an x, remember you try to isolate x so that it's finally on its own. But with absolute value, think of them as impenetrable parentheses, right? So you can't distribute into them and you can't take anything out of them. They're impenetrable, okay? Like waterproof. Nothing's coming out, nothing's coming in. So you have to isolate the absolute value first and then unravel to get x alone. So then the question becomes, how do I drop the bars? Well, to drop the bars, I want you to do just this. I want you to take the negative and the positive of the outside number. So that's why it's important that you unravel everything so that you just have the absolute value. So, since the absolute value is isolated, to get the bars to drop, I'm going to take negative 8 equals x minus 4 equals 8. Oh, something under the table there. Again, this is the same, well, not again, first. This is the same thing as having x minus 4 equals negative 8. And, x minus 4 equals positive 8. But rather than doing it in 2 different equations, I like to do it just in one fell swoop. Okay, just time management, if you would. So now, the last thing we have to do is add 4 to all the sides. So now we have that x equals negative 8 plus 4 is negative 4. And 8 plus 4 is 12. So x equals 12 and negative 4. And there you go. All right, so now number 3. All of these are a little bit different, so I understand if you don't pause the video and try it on your own, but I would like you to, okay? If you think about it and you can pause the video to try it on your own, awesome. But if not, you're not ready for that, that's fine. You'll get practice with the homework. Okay, so number 3. So there should be something glaringly wrong with number 3. What is it? Yeah, what's it equal to? A negative number. What did we say from the definition the absolute value measures? Distance. And that whole ramble on about distance cannot be negative. So here, what do you think the answer is? No solution. Right, so that's either the empty braces or the 0 with a line through it, right? So there's no solution here because we can never, ever, ever have an absolute value equal a negative number. Because remember, an absolute value always spits out a positive number. So positive can never equal a negative number. So hence, again, why no solution. All right, so now number 4. Actually, I would like you to pause the video and try number 4. And then press play when you're ready. All right, so number 4. Number 4 is okay, but we have to do some isolating first. Remember, in order to solve this, we want to get it down to first just the absolute value bars equal, and then we'll whittle our way down to x equals. So, just like socks and shoes, we have to unravel, right? We have to go to a bare foot. So now we're doing order of operations backwards. Have to take our shoe off, then our sock to get back to the bare foot. So that means we add the 10 first. Then we divide by the 2, right? Again, because we're doing the order of operations backwards. Now we've isolated the absolute value, excuse me. So what do we do to drop the bars? We take the negative and positive of the outside number. I like to keep, and you should too, keep your negative on the left-hand side, right? Just kind of keep it in numerical order. Negatives on the left, positives on the right. And then last step, right, subtract 5 from all sides. So we get negative 10 and 0. Oops, negative 10 and 0. So the two values that would get us to equal 0 are negative 10 and 0. Okay, so last but not least, same process, but just visually different. So hopefully you all would agree we've got an absolute value equals an absolute value. Totally fine. Nothing wrong with that. Nothing at all. So what we're going to do is the same thing. How do we get the bars to drop? We take the negative and the positive of the outside thing. Well, in this case, the outside is not just a number, but it's a term, which is fine. So we're going to do the same thing. I've got 2x minus 5 equals the negative of the term and 2x minus 5 equals the positive of the term, which is just x minus 6. And now we need to solve each equation independently, right? So we can't really do the shortcut method here because we have different signs. So on the left, we're going to start by distributing. Actually, at this point, pause the video, try it on your own, see if you get the same answer as me. So now, 2x minus 5 equals negative x plus 6. Combining like terms, I'm going to add the x over, add the 5 over, so I get 3x equals, what is that, 11? And then divide by the 3, so I get 11 thirds. And over here, we are going to combine like terms, so I'm going to subtract the x over, so that's an x. I'm going to add the 5 over, so that's a negative 1. So x equals 11 thirds and negative 1. Again, if you have any questions, please feel free to email me. LD 1168.